Hello guys, this is Edgar here. Today we want to talk with about EtherChannel. EtherChannel is a port channel technology developed by Cisco, and the purpose is to group several physical interfaces into one logical channel, and the most important, provide more bandwidth. Cisco version called PagP, or Port Aggregation Protocol. The standard of Ethernet channel is IEEE 802.3AD, or Link Aggregation Control Protocol. The port aggregation protocol provides up to 8 interface groups. The link must have the same speed, duplex, and VLAN configuration in the same bundle. So we cannot have uh, one switch with VLAN 10 and 20 and another switch with VLAN 30 and 40 and try to make the bundle, because it isn't going to work. A couple terms we need to know before we go into the lab. Port channeling refers to combining 2 to 8 fast Ethernet interface or 2 gigabit interfaces into one logical link. So for fast Ethernet, which the bandwidth is 100, we can combine or group 2 interface to 8. No more that, no more less. For gigabit interface only, we have two interface bundle. The channel group, this is the command on the Ethernet interfaces, uses to add the specified interface to a single Ether channel. The port channel ID is the number associated to the Ether channel group, and the interface port channel is the command to create the bundle interface. So let's go to the lab. Okay, in this topology, I have two switches, two multi-layer switches, 3560. I already set up the VLAN 100 and VLAN 200 on each switch, and I set up the interface fast 1 and fast 2 to be in trunking mode and allow only VLAN 100 and VLAN 200. And I have the same configuration of the FR F1 and F2 for the MLS2. So the first thing we need to do is to bundle the interface to a channel group. To do that, we need to be in crowd configuration mode. We need to be inside the interface. So interface range is a good command to do this, because we're gonna work with 2 or more interfaces at the same time. So interface range fast Ethernet 1 to 2, and the command to do this bundle is channel group 1, because 1 is the ID for this group, and after we need to put the mode of this channel group. The mode can be or the standard, which is LACP, or Link Aggregation Control Protocol, or we have the proprietary Cisco is the port aggregation protocol. So we have active, auto, desirable, on, and passive. Active, passive are for LCP. We can put on MLS1 we can put the mode active, and MLS2 we can put the mode passive, and it works. It's gonna work. But we cannot use MLS1 active for LCP unconditionally, and MLS2 desirable, which is PagP unconditionally. So we need to select the best for our needs, the best Ether channel for our needs. In this case, I'm going to use LACP, Link Aggregation Control Protocol. So I need to put active. Once we got that, we're creating the port channel interface, and the name is port channel 1, and for short is PO1. Okay, once we have that, we need to create the logical interface. The logical interface is channel interface Ether channel, interface port channel 1. 1 is the ID number for the group. Interface port channel 1, and with this command we set up the the logical interface for the Ether channel, and we need to assign the same information from fast Ethernet 1 and fast Ethernet 2 to this interface. So we need to put this in switch port mode trunk, but I need to put the switch port trunk encapsulation, that one queue, because this is a layer 3 switch. In a layer 2 switch, we don't need to use switch port trunk encapsulation, that one queue. And after switch port trunk mode, switch port mode trunk, and after I'm going to allow only VLAN 100 and 200. Okay, that's all we need to have to configure the Ether channel on the MLS1. I need to do the same on MLS2. Conf-T. I'm going to the interface range, fast Ethernet 1 to 2. The channel group we need to create, channel group 1, and the mode is gonna be active, or we can use passive, because the MLS1 have active. So passive enable LACP only if a LACP device is detected. So we're gonna use passive. Okay, we create a port channel 1 interface. We need to create the logical interface port channel 1. We need to create the trunk, this interface associated with the same information about fast Ethernet 1 and 2. Switch port trunk encapsulation, that one queue, switch port trunk, switch port mode trunk, switch port trunk allow VLAN 100 and 200. I'm going to write the information in the RMB RAM. So we got left connect both switches, fast Ethernet 1, fast Ethernet 1, fast Ethernet 2, fast Ethernet 2, and wait for the bundle. We can check the show interface port channel 1, and we see the protocol is down and line is down. So I'm going to use conf-T interface port channel 1. I'm going to shut and not shut the interface. I'm going to use the same for this switch. Conf-T interface port channel 1. Shut, not shut. Interface change state to down. Okay, we need to check why this message appear. So show IP interface brief. Okay, we got the fast Ethernet 1 and 2 down, so we need to turn off that interface. Conf-T interface range fast Ethernet 1 to 2 not shut. Okay, that was the problem. And do show IP interface brief. Let me check. We got the fast Ethernet up. Okay, in this switch we don't have problem, and the port channel is up also. I'm going to use the same command to verify the port channel in this switch. Show IP interface brief. Okay, we got up. Okay, great, nice. When the green lights are on, we got a good one. Okay, let's see why this switch has the amber lights. We can use show EtherChannel summary command to verify the information about the EtherChannel. We see we have We have the number of channel groups, which is 1. We have the port interface. The interface logical about the Ether channel is 1. The protocol is LACP because we are running active in one and passive in other. We got the ports which are assigned to the Ether channel, which is facetnet 1 and facetnet 2. Another command we can use is show Ether channel summary. This is show Ether channel summary. Show Ether channel port channel. Show Ether channel port channel. And with this command, we have the group. We have the age, 6 minutes and 27 seconds. We got the logical ports, the number of ports. We got the protocol, which is LACP, and we have the information about the last port bundle, which was a minute ago, 2 minutes ago. So I got to show you last stuff about this port channel. When we create port channel on switch, the spanning tree protocol read the interface like 1. So before I create the port channel, the spanning tree gonna show facetnet 1 and facetnet 2, which can be designate or blocking or designate. So I'm going to show you show spanning tree VLAN 100, for example, and spanning tree see the port like 1. So that's good. That's a good because we can create up to 8 for port aggregation protocol for Cisco, up to 8 interface, and in logical mode for the switch, it recognizes like 1. So both ports in the switch on the spanning tree is seen by 1. We don't have facetnet 1, facetnet 2, and port channel 1. So I'm going to check this information on the switch 2. You see, we get one is root because this is the root bridge. This is the root bridge. The port is designated and forwarding, and the port is in root because the root ports are the ports with the lowest cost to the root bridge, and it's in forwarding. And the cost, which we don't want to talk about that because it's not for CCNA, is 9. And this is 9 because about the Ether channel. So anyway, this is all for now. I hope you like the video and understand what Ether channel does. And if you had a question, you can answer below.